Introduction to Geography. Good morning, everyone. Today, we begin our exploration into the fascinating world of geography and earth science. When most people hear the word geography, they think of maps, countries, and perhaps capital cities. While that's certainly part of it, geography is far more expansive. It is the study of places, spaces, and the dynamic relationships between humans and their environment. It's about understanding why things are located where they are, how they came to be that way, and how they interact with each other. Geography is both a physical science and a social science. It can be divided broadly into two main branches: physical geography and human geography. Physical geography focuses on the natural environment, the landscapes, climates, landforms, and processes that shape the earth. Human geography, on the other hand, is about people, population distribution, cultures, economies, and the built environment. Our focus in this course will lean toward physical geography, which is deeply connected to earth science. But as you discover, the physical and human side of geography are intertwined. You cannot talk about landscapes without considering how people use them, and you cannot discuss climate without thinking about how societies adapt to it. What is physical geography? Physical geography is essentially the study of Earth's natural features and the processes that operate upon them. It examines the mountains, rivers, oceans, climate systems, soils, vegetation, and the atmosphere, all in the context of space and time. Physical geography seeks to understand the why and how behind the planet's physical characteristics. Imagine you are standing on a coastline. The physical geographer would study how that coastline was formed by waves, tides, and currents, and how it might change in the future through erosion, storms, or sea level rise. They will look at the climate patterns that influence the vegetation there, the type of soils in the region, and even the tectonic processes deep beneath the surface that may have uplifted the land. Human versus physical geography. While human geography examines human patterns such as migration, economic activities, and urban development, physical geography deals with the systems that exist regardless of human presence. But here's the important point: these two are constantly influencing each other. Humans build cities in areas with favorable climates and fertile soils, but our actions, such as deforestation, urbanization, and industrial activity, also alter those same physical systems. This interconnectedness is a recurring theme in environmental science. Humans are part of nature, not separate from it. The four great spheres. The Earth system is often conceptualized as being made up of four interlinked spheres. Lithosphere, the solid earth, rocks, mountains, minerals, and the ground beneath our feet. Hydrosphere, all the water, oceans, rivers, lakes, groundwater, ice caps, and glaciers. Atmosphere, the layer of gases surrounding Earth, essential for weather, climate, and life. Biosphere, all living things, plants, animals, and microorganisms. These spheres are not isolated, they constantly interact. For example, a volcanic eruption, lithosphere, can release gases into the atmosphere, change weather patterns, melt ice in the hydrosphere, and impact plant and animal life in the biosphere. Understanding these interactions is critical to physical geography. Tools of geography. To study these systems, geographers use a variety of tools. Traditional methods involve maps, field observations, and statistical analysis, but today's geographers also rely heavily on remote sensing from satellites, geographic information systems, GIS, and computer modeling. Maps are the cornerstone of geographic work, but modern maps are dynamic, digital, and data-rich. With GIS, we can layer information, such as vegetation, population density, and rainfall, to see patterns and make predictions. Map making. Map making, or cartography, is both an art and a science. A map is a simplified representation of the real world, but it must be accurate enough to convey the needed information. Different types of maps serve different purposes: topographic maps for showing elevation and landforms, political maps for showing borders, thematic maps for illustrating patterns like climate zones or income levels. The choice of scale is crucial. A large-scale map shows a small area in great detail, while a small-scale map covers a large area with less detail. For example, a neighborhood street map is large-scale, a world map is small-scale. Geographic grid, latitude and longitude. To pinpoint locations on Earth, we use the geographic grid, a system of imaginary lines. Latitude lines run east-west and measure distance north or south of the equator. Longitude lines run from pole to pole and measure distance east or west of the prime meridian. Latitude is closely tied to climate because it determines the angle at which sunlight hits the Earth. Near the equator, sunlight is more direct, leading to warmer temperatures. Toward the poles, sunlight is more oblique, leading to colder climates. Isolines. Isolines are lines drawn on maps to connect points of equal value. The most familiar example is the contour line, which connects points of equal elevation. Meteorologists use isobars to show areas of equal pressure, and isotherms for areas of equal temperature. Isolines make it easy to visualize gradients and patterns across space. Topographic maps. Topographic maps show elevation, relief, and landform details through contour lines. They allow us to visualize the three-dimensional landscape on a two-dimensional surface. These maps are essential for planning construction, hiking, environmental studies, and military operations. Geographic Information Systems, GIS. GIS is a technology that allows us to capture, store, analyze, and display spatial data. With GIS, you can combine layers of information, such as soil type, vegetation, elevation, and rainfall, to assess environmental suitability, plan urban growth, or monitor deforestation. GIS has become an indispensable tool in geography, urban planning, disaster management, and even marketing.